explorers, and welcome to another video. Today we are going to talk about PWNKit. And this is an interesting bug that was found in Linuxes and has been there for more than 12 years. So let's just jump right over to my screen here, and you see that I have a Linux box here, which I called exploit, because this is where I'm gonna show the exploit. And if I run the command PWNKit here, you can first off look at my ID. We see that I'm the user Wooden, a regular user that doesn't really have any extra privileges. But if I run PWNKit here, then I'm a root on the system. And this is not really good that you can become root on any system. It's something that elevates your privileges on the system. So let's go back a little bit and look at some prerequisites here. So first off, if we go here and look at this screen, this is my install screen. And this is what I install on this Debian system. And usually when I install regular server system, I don't install the desktop environment. I only install SSH and the standard system utils. And when I do that, I don't get a package called PolicyKit-1. And PolicyKit-1 has the executable called pkexec. And this is something that is run as root and gives users access to run specific programs as root, even though they don't have those privileges. So that's the problem here, that we have a program similar to sudo that should give you the possibility to run things as root that has a problem in it. You need to have the desktop environment. Usually you also have the print server checked here, but I never install a print server because I don't really use the desktop environment. But if you have a desktop environment, that is of course something that you want. So let's go over here and look at the specific exploit. So this is code from the pkexecute, and this is shown on the Qualys homepage. This is a blog by them, which is really good written up. And if you want more insights, read this blog and watch the videos. But I'm just gonna take the code from here in order to show you where the problem is. So here we have a main function. We give it some arguments. So this is the counter of the arguments, and here we have the actual argument. And then it goes through each argument and checks the validity. If this, for instance, could be 0, no arguments, or 1, then this for loop would do pretty much nothing, right? And this n character here will be set to 1 every time. Will not have any other set here. So that when it picks up this argument 1 here and gets a path, if this argument doesn't contain anything, you will pick up something in memory. And then you go down here and you do a lookup, and it's probably not slash, whatever you picked up in memory. And then you will find the path for that thing, and then you will set the specific path to that, and also this S parameter, the program that you actually found, into this argn here. And another thing that you need to know is that the arguments come first in memory, and then they have put the environment variables directly after these. So if the arguments are non-existent and you just put null there, which terminates the arguments, what's the first argument here is actually a lookup into the environment variables. So you will get a path for the environment variables here, where you can look up something and then go back and find that specific program in that path, possibly. And when you have that program in that path, you will put back that program into that specific environment variable again. So you will modify an environment variable by doing this. So here they have a show of this, that you can take the first environment variable here, which is value, and then they take the second one, which is the specific path. So this is 1 and 0, and then they will push those together and create one path of it. It's a little bit complex, but it's interesting that this actually works. So this PWNKit then, if we look at that, this is the code that we ran. I downloaded this and then ran this GCC here in order to build it, so I know that I have built this specific code, nothing else. And if we look here, first off, they have some things to just remove things afterwards, so unlink files and remove folders and so on. Not really important, but if we look here at entry, which is their main function, I don't know why they build this with entry as the main function. I would have used just main, but I guess there is a reason for it. So here they put up some different variables that we use later on, and here we see argc and argv, and argc is a pointer somewhere, and then argv is another pointer. And here we have something really interesting. Here we create a conv path directory. So this is the directory name. It looks very strange. Conv paths equals dot, and we see if we can create that directory. And that's important because of the environment variable, because conv path is an environment variable that we want to set. And then we create a file called conpath pkexec, and we will create a directory called pkexec here, and then we will put the modules in there. We will open a file and write a module in there, and the thing we want to write in here is the module pkexec2. So this is the information that we put into that module, and this gconf module is something that can be ran before any other program is run. And gconf path is something that is connected to the command iconv in Linux, which converts characters encodings in memory for different programs. And in this case, we put a module in that can be ran when this iconv is loading in new models to handle character encodings. So then we will put ourselves in as this SO here. So we will build a program that could be the library for this, and put that in this pkexec SO, so it will be loaded by this gconf module. And then we will see that we have done that copy, and we will check here that we can actually exploit this, that everything is set up. If we can't, then we will just remove these paths, because we can't do anything here. The environment is already patched and done, and we will close everything and go on. Otherwise, we will create an argument set here, which is null. So we don't have any arguments, and we terminate the arguments with a null character. So the memory will not have an argument here, not even the program. Usually in Linux you have the program as the first argument, and or the 0th argument, and then you have all the program arguments. And then in Unix it's that way. And then we will go in and create this environment variable with this pkexec in the beginning here, the path conv here. So path conv path, and then charset and shell a pkexec. So all of these things will be put into the environment variable. And as we knew, we will take this executable and put that as a slash on this path in order to see if we find that here. And because we have already created that file up here, we know that it exists and it's executable. And then we will just run pkexec with these arguments and this environment. And this means that this specific file will be loaded in the sudo environment or the super user environment before it actually runs the command. Because if you don't have any arguments up here, it will probably not run anything. But before it's actually trying to run something, the character encoding module is run. And this is this configuration, this little code down here. So we have a gconf here, gconf init. So this is something that is ran before in the super user environment. And what it does is look at removing these paths. So we clean up after it ourselves. And then we will check if the environment command is available. And if it is, then we can run just shell and get the specific command that we put up here. So we could actually put another command up here if we want, that we want to run. Or if this environment variable is not set, then we will try to run bash, and if that fails, we will try to run sh. So this is the way to get this shell as root in your environment using this exploit. So this has been found a couple of months ago. That's why I'm covering it now, because I don't want it to be too close so people don't have the opportunity to upgrade their systems. And another thing is I had to download an old image and install it locally without any internet access, or else it would upgrade itself and install the newest packages, and then I would not get this to work at all. So it has been patched for a while, but it's important to upgrade your system, and this policy kit needs to have a new version in order to remove this possibility to escalate yourself into root. Another thing we saw was that this command is not even available in a regular Debian server, and perhaps it's not even installed on other environments either. So you might not have this package, which is a good thing. But in a normal desktop environment, you could escalate yourself and move yourself into being a root on that system and do a lot of harm if you are not careful. So that was what I wanted to cover today. I hope that you found this interesting. Maybe you have heard of this exploit but haven't really seen how it works. Then leave a comment in the comment section down below. If you know more about the exploit, I would love to hear about that as well. If you thought this was interesting, leave a comment about that. And if you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.